Well, let's go ahead and get things started. Welcome and thank you very much for joining our session today, Augmenting Presto and Trino with Autonomous Indexing. My name is Lee Razzo from Cloud Native X. Today, our webinar is going to be presented by Ojas Mulai of Varada Solution Architect, Presto expert, and expert on all things big data analytics. So very excited for this. Just to kick things off and get an idea where everybody's coming from and where the interests lie on this session, I'm going to launch just a little poll. What flavor of Presto are you currently using? Just if you can select any of these that apply, including the last option, which is that you don't use Presto yet, this will give us a little bit of a sense of where the audience is coming from. And while you do that, we'll turn it over to our host, Ojas, to take it from there. Thank you very much, Ojas.
Thanks, Lee. Thanks, everyone, for joining. As Lee mentioned, we are going to cover more in terms of how you can accelerate your Presto or Trino queries. Right? Varada provides a solution which will allow you to autonomously index and accelerate the queries on any Presto flavor which you're currently using within your environment. A quick history of who we are. Varada was founded by experts in storage and data at Extreme.io. We were founded in 2017, and the company Extreme.io was acquired in by Dell EMC. So we have a lot of expertise in terms of the data storage, the data layouts, and how you can optimize it for big data workloads. The company is based out of both Israel and Silicon Valley, and we are backed by some of the leading venture capitalist firms. In terms of the solution which Varada provides, one of the key value adds we provide is in terms of how you can accelerate the data which resides within your data lake in your own VPC, right? And leverage the solution to accelerate those in a seamless, adaptive, and dynamic fashion. Right? Think of it as you have SQL consumers who are accessing the data that resides into the data lake. The Varada solution would be deployed within your own VPC. So it's all self-contained within your VPC with no outbound communication. So in terms of security, you can provide your own firewall rules, own policies in place. The solution itself sits between the SQL consumer and the data that resides within this data lake, right? So you can query the data in its original format, which could be in columnar formats like Parquet, ORC. And Varada operates as a middle tier, listening to the queries that are being executed by the SQL consumers on the data lake. We leverage Presto or Trino as a big data engine to implement our technology. And given we are a middle tier between the SQL consumers and the data, we are able to listen to the types of queries and that are being run on this data lake. Based on these query patterns, we can now build adaptive and dynamic indexing so that you can get almost 10 to 100x improvement in terms of the performance. These indexes are built dynamically based on the type of column you're trying to access or the underlying data set that is being accessed, right? So as your data patterns changes, your data sources changes, given we are a middle tier and we can understand those, we can dynamically adapt to those changes. Right? Again, other area you can look at it is in terms of the time horizon. Users continue to query data maybe 7 days, 30 days, 1 year, a different time horizon. So as those time horizons changes, we can also start and continue indexing the new data that continues to flow in. The last piece around this is we act as a seamless layer between your SQL consumers and the data lake. So if you're currently using any of the Presto flavors, you can leverage our platform without having to change or rewrite any of your queries. So you would use the standard SQL interfaces like Tableau, BI, dbeaver, right? All connecting to the Presto ODBC, JDBC drivers. So let me get into a quick demo of the environment. And hopefully that will provide you more insights into what the platform provides. So in terms of a demo environment, I have a public data set, which is a ride sharing application data set. This data set can be used by marketing and product teams for segmentation, user behavior, different kinds of use cases, right? In terms of the actual data source, these are Parquet files compressed, uh, organized in um, partitions, partitioned by date. So every day you have a new file that is being dropped within that particular partition, right? In terms of the overall data size, this is almost 1.5 terabytes compressed data. And this particular table has almost 27.6 billion rows within that table. Let me switch to the demo environment and walk you through that. So two things which I alluded to earlier. Given Varada sits as a middle tier, we can listen to the queries. So this is our Observatory Dashboard, which looks at the type of queries, what's happening within the system, and provides that information to our engine to really build the acceleration that you're looking for. Right? So as you can see, this is connected to one of the Presto clusters that is running within my environment. It's a 2-node cluster, uh, a very fairly small cluster footprint. And based on that, I can get all the information that is happening within my data lake. Right. Few things to note here is you could see, hey, who are my top users? What are my top tables? And this information is used by the platform to build the indexes on the fly. Right? These indexes are stored on an ephemeral SSD, which is attached to the nodes within the Presto cluster. Right? So think of R5Ds or i3 instance families within the AWS environment, which are used as your Presto cluster EC2 instances. Cool. So we also provide a query editor to start doing ad hoc analytics, and you can also bring in any of your own uh, query editor tools if that is of your choice, right? Uh, so what I'm doing right now is this is a cohort analysis query based on the data set which we just looked at. Let me run it for the first time. Think of it as Varada does not exist at this point. It is directly going and querying the data lake. It doesn't have any indexes available within the Varada layer to really take advantage of that. So at this point, it is directly going to the data lake, looking at the S3 data, fetching that, passing it on to the Presto instance, and then running the query through it. Right. So what happens as part of this query is we'll piggyback on this query, and based on some of the key attributes which I'm accessing. So in this case, based on this particular query, I know I can really take advantage of driver ID that can be indexed, and that can increase the system performance. So what it will do is, as part of this query, it will piggyback on that query and uh, and start building the indexes on the SSD layer which we have. Right? So this takes almost a minute and a half. As you can see, it's already almost 9 billion rows that are being processed as part of it. Right. So indexes are not in place. It's querying the actual data and trying to get the data from the data lake while the indexes are being built. Right. So that's what is happening. And while we are building these indexes are fairly small nano blocks, which are 64K rows of a single column within your file that is being pushed to this ephemeral SSD that is attached to it, right? So that's how you would experience the system when it is completely warm or when there are no indexes that are currently built into that, right? So while we are waiting for this query, let's run a quick uh, poll. Lee, can you run a quick poll, and we'll get back to this once the query execution is complete.
So just for clarity, you should see a poll. Are you having challenges with your Presto? And select all of them that apply.
Okay, cool. So while we are waiting for this query to execute, there are a few other things that you can look at, right? So one of the things is, if you are aware and know what columns you want to accelerate, you can directly go ahead and define what acceleration rules you want to define. So in this case, you can go to the driver ID and select that and say, hey, accelerate this column. There are different materialization types you can apply to really accelerate that. So this is a scenario where I know my data set, I know what needs to be indexed, and I'm leveraging that, right? And you can do it for a specific partition or a rolling time window as well. So both those options are available, or you can do it on all the things, right? So that's one scenario. The second scenario you can think of is, as soon as your data lands within your data lake, you can start building those indexes. So the first time your users start accessing that query or accessing that particular column, they can get the benefit out of it, right? So I think this is done. Yeah. Yeah. So it took almost, as you can see, it took almost 3 minutes, right? 3 minutes in terms of uh, the number of the total execution time, right? And in terms of the total rows that were returned, it was almost 10 billion rows, right? So let's go back to the query editor. Copy this. Let's go back to the query editor. Okay. So as I mentioned, while it was doing this, it kind of built those queries it kind of built those indexes in the backend. And now, as soon as I run it again, I can see the elapsed time is almost 1.2 seconds. So it came down from 180 seconds to 1.2 seconds. The amount of processed rows was drastically reduced as well, right? So from 10 billion, it came down to almost 2 million, right? So that's the kind of advantage you can get with the help of indexes, right? So you might say, hey, this sounds great, but are you doing results cache, or is this data being cached within somewhere? That's why it's giving you such a drastic improvement from 180 seconds to 1.2 seconds. Well, no, that's not the case. It's just because the indexes are there, and now you can take advantage of that. So I can change my queries to say, hey, let me look at the cohort of drivers who had more than 20 rides, right? So it's a different data set that needs to be processed, but given the indexes exist, you can still get the response time in almost 1.5 seconds. Okay? And more selective your queries are, the more benefit you can get out of these queries. So in this case, I can say, hey, let me be very selective where I'm looking for a particular driver ID and see how the cohort analysis works for him, right? So I can say 103,456, that's my driver ID, and let's see what I can get out of it. Right? So again, in this case, given it was much more selective, I almost got a sub-second query response time for this particular query, right? You might also have data that is arriving every day. So in this case, let's say this is for the first 31 days, I'm looking for a cohort analysis, but now today I have got a new data for February 1st, right? So I can say, let's look at February 1st data set and see how this translates to that, right? So in this case, for the first 31 days, indexes have been built because we ran those queries. And for this new data set, whenever I run this query, it will fetch the data from S3 for this one particular day. But as part of this query, it did piggyback on that particular query. and build an index for this one particular day. So the next time you query this uh, Jan 1 to Feb 1 timeframe, it will directly go to that index that is built and fetch the data. Hopefully that gives you enough understanding of how the platform works, where it can provide you um, the value around it. Right? Let me switch back to that. Okay. So now we looked at, hey, how this all works and how we can take advantage of it. But let's look at under the hood and see what exactly happened and how the system reacted to um, the things that we saw in terms of the performance, right? So this is the same cohort analysis query. What the system did is, based on the query patterns, it built different acceleration strategies, saying, hey, the last point is a highly selective one. It can take advantage of the indexes if they are there. Similarly, uh, for this TR, it can take advantage. It's frequently used. So cache can be a better option for that. Or for driver ID, a combination of these strategies might be a better option for that, right? So based on the learnings which the system was observing, it started building these acceleration strategies and then implemented those strategies to give you the acceleration which we saw, right? Uh, so how we do that? So once the acceleration strategies are built, we look at we build nano blocks. These are 64K columns, 64K rows of a single column within a file within your data lake, right? And depending on the type of column you have, there are a variety of indexes that you can build, which will be different nano blocks that are laid down within the NVMe SSD space that is allocated to the cluster, right? So think of it as an operational state. You have this middle tier, which is our Varada layer, which is NVMe SSD, and it has these all millions of nanoblocks, each pointing to 64K uh, rows within a single column in a file, right? Uh, Whenever a user starts accessing or running a query, it will look into this nanoblock, which is within the NVMe space, and see if that index exists. If it exists, it will return the data leveraging the index. If it doesn't, it will directly go to S3, fetch the data, build the indexes for that, and store it in the space. So the next time you access it, it's all available within that space. So that's how the system works. In terms of what are the real use cases where we see this solution being used by our customers, right? Uh, Users are looking for interactive performance on BI dashboards on the really granular data, right? So they are looking at terabytes or petabytes of data and trying to build their analysis based on these BI dashboard, right? So these queries are fairly selective, uh, and they can really take advantage of the indexes that are built as part of it. So that's a very common use case where we see the Varada solution being used by our customers, right? The second area where we see is there are a lot of data products that are tied to this interactive performance, right? So you can think of the same rideshare applications, right? It requires an a very sub-second response times for the user engagement and user behavior, and makes leverages that to build those decisions around it. So whenever our customers are building any data products that rely on interactive performance, we see this solution being leveraged as well, right? Cool. So just to summarize a few key takeaways out of it, right? One thing is adaptive and dynamic indexing is kind of key. As your business change, as things change, you do not want your users to build those indexes manually or maintain or align to that based on how your business change. So the system needs to be able to understand and make those adaptive and dynamic changes. Uh, that's where the solution comes in. You don't want to have any additional overhead in terms of data ops. So that's kind of one of the key value add of the solution. We saw that the amount of data that we scanned for that same query reduced from almost 10 million rows to 2 million, right? That enabled us to use less compute for those kind of queries, right? So we almost were able to reduce the TCO to 40 to 60% decrease in terms of the compute cost, right? So it's both in terms of performance as well as cost, you can benefit based on the indexing that is happening within the system, right? And last, in some scenarios, we have seen almost 10 to 100x faster response times while you're querying the data lake. And this has really helped our customers and users to build the data-driven products that can really make a difference for their business. With that, I'll pause and see if there are any questions.
Excellent. And just for anybody who joined a bit later, and at the bottom of your screen, there is a Q&A button that you can press to submit any questions you may have. And we do, in fact, already have a couple of questions in there, Ojas. The first question is, how does the solution differ from caching solutions or other query acceleration tools like Dremio?
Cool. Thanks, Lee. Yeah, so two things, right? So one is caching solution will allow you to give you that faster response time, but the memory footprint is quite large, right? And some of these caching solutions or other query acceleration engines will perform pre-aggregations, so the granularity of the data might be lost. So you really need to know how your business is going to query the data to do that, right? So there's a lot of data ops that can be involved with some of these solutions, right? What we provide is this dynamic and adaptable solution where it kind of learns based on your query and user patterns and really adapts to that to build those indexes on the fly. So if those indexes are not used after a certain point of time, we will even drop it so that you can leverage the space that is available to provide acceleration to other query patterns. So that's kind of the key difference in terms of how you leverage caching versus indexing. So hopefully that answers the question.
All right. And in fact, coincidentally, the next question I see is about space. How much space does the index take, and how do I identify how much I need to index to gain the acceleration?
Got it. Cool. So there are two things. These indexes reside on the SSD layer, which is attached to your Presto cluster, right? So you can define, there are two metrics or two ways to look at it. One is you can say, hey, this is my data lake footprint, out of which I want to accelerate a certain percentage of that. So you can say roughly what we see within a customer base is 20% of your data lake is your hot data, and that's what they want to accelerate. And that's kind of one metric of saying 20% of my overall data lake space is what I want to accelerate. So that's how manage that. And that's where I store the indexes, right? The second metric to look at is I have some certain customer facing SLAs, and I want to make sure that my system is able to react to that. So in that case, you can define, hey, these are my SLAs, sub-second, 1 second, 2 second, whatever you have. And the system will build those indexes based on the SLAs you're looking for. So in that case, it might have to materialize or index a larger footprint of your data lake to provide you that SLA. So those are the kind of the two metrics which a user would define to really figure out how much index how much space you want to allocate for these indexes.
Okay, great. Thanks for that, Ojas. I have one more question. How do you handle elasticity in a cluster?
Okay. All right. So it looks like there are folks who are using Presto for a while and have seen the need for the elasticity around Presto and how it can operate with your query engine, right? So that's a very valid question. Elasticity is inherent in your leveraging any of these cloud solutions. So what we have built as part of this Elastic framework, let me actually go slide and see. Okay. Yeah. So what we have built as part of elasticity is as your clusters grows and shrinks, right? These indexes, which are stored on the ephemeral SSDs, which we call it as hot data within your Presto cluster, right? As your cluster scales out and scales in, we make sure that these indexes are offloaded to S3 once they are built, so that you have a new layer of warm data and index that resides on S3, right? So if your node goes away, if you scale down at the end of your peak business hour, those indexes still reside in your S3 layer. So the next time the cluster scales up, we look at this warm data, which is available within your S3 location, and pull it back into the hot tier whenever that is accessed, right? So there are different tiers of data of how you can manage. One is a hot index, which resides within your Presto cluster on the NVMe SSD node. The second thing is the warm index, which resides in S3. Those are indexes that are built and offloaded when the node goes away. And the third is your whole data lake, right? So again, if the data doesn't reside in either the hot or the warm tier, we always go to the cold data lake and fetch the data and index it on the fly, right? I think one key metric here, which we have seen based on the usage in the customer base, is offloading this index to a warm data within S3 almost provides you a 10 to 20x improvement in terms of performance, right? So again, what you built is not lost. We do offload it and make sure that it's available for you to use. Hopefully that answers your question.
Yes, excellent. Thanks. Thanks for that, Ojas. And how can someone contact you if they have a question later on?
Sure, you could I'll share my email address with this, but you can also reach out, go to our website, and from there there's a contact us option. Happy to chat with you guys.
Excellent. Great. All right. Well, thanks very much, Ojas. It's a great presentation. Thanks for everybody for joining. We will be making a recording of this available. So if you attended or registered, you will receive a notification when that's available. And we look forward to many follow-up sessions from this. Thanks very much.
Thanks everyone for joining.